Welcome to Innovation Pulse, your quick, no-nonsense update on the latest in cleantech and EVs. First, we will cover the latest news. Hyundai's INSTER and Kia's EV3 have taken top honors at the 2025 New York Auto Show, showcasing cutting-edge design and sustainable innovation. After this, we'll dive deep into the parallels between the historic ozone layer recovery and today's climate change challenges. Stay tuned. At the 2025 New York International Auto Show, Hyundai's INSTER won the 2025 World Electric Vehicle Award, chosen by a jury of 96 automotive journalists from 30 countries. The INSTER is celebrated for its design, range, and technology. It offers a rapid charging capability, going from 10 to 80% in about 30 minutes, and provides a range of up to 230 miles. Despite its absence from the US market, the INSTER is expected to be popular in Europe, China, and other regions. Hyundai's success continues with previous awards for models like the Ioniq 5N, Ioniq 6, and Ioniq 5. The company's focus on innovation and value in the electric vehicle sector is evident, and it remains a strong contender in the global automotive market. What will Hyundai achieve next? Time will tell. Let's now switch to the impact of sustainable innovations. The Kia EV3 has won the 2025 World Car of the Year Award at the New York International Auto Show. The EV3, praised for its cutting-edge design and technology, follows Kia's previous successes, including awards for the EV9 and EV6 GT. The EV3 is noted for its bold exterior, spacious and functional interior, and impressive range of up to 605 kilometers. It features fast charging capabilities and advanced technology like AI assistance and driver assistance systems. Already popular in Europe, the EV3 is among the top-selling EVs in several countries, including Spain, Ireland, and the UK. Kia's president and CEO, Ho-Sung Song, expressed pride in the award, emphasizing Kia's commitment to innovative and sustainable mobility solutions. The EV3's success underscores its potential appeal in global markets, including South America, Asia, and beyond. And now, pivot our discussion towards the main cleantech topic.
All right, everybody. Welcome to another deep dive on Innovation Pulse, where we explore groundbreaking solutions to global challenges and their real-world impacts. I'm your host, Donna.
And I'm Yakov Lasker, joining you for today's conversation about something that was once front-page news, but has mysteriously vanished from our collective consciousness: the ozone hole. Remember that? It was the environmental crisis everyone was talking about in the 80s and 90s.
Oh, wow. Talk about a blast from the past. I definitely remember those dire warnings about the ozone layer when I was younger. There was this genuine fear about increased skin cancer, ecological damage. It felt like an impending disaster. But you're right, Yakov. We barely hear about it anymore. So what happened? Did we solve it? Did we just move on to other concerns?
That's exactly what we're digging into today. It's a fascinating story that begins in the early 1970s, when scientists first started raising alarms about certain chemicals potentially damaging our atmosphere. Donna, do you remember hearing about CFCs as a kid?
Chlorofluorocarbon S? Yes, they were in everything from hairspray to refrigerators. I vividly remember my science teacher explaining how these invisible gases were floating up and creating this huge hole in our planetary shield.
Precisely. The scientific detective story began in 1974 when two chemists, Sherwood Rowland and Mario Molina, published a groundbreaking paper in Nature. They hypothesized that CFCs, these stable, non-toxic chemicals that were perfect for everything from aerosol sprays to air conditioning, could drift up to the stratosphere where they would break down and destroy ozone molecules.
Which was alarming because the ozone layer is essentially Earth's sunscreen, right? It protects us from harmful ultraviolet radiation.
Exactly. The ozone layer absorbs about 97–99% of the sun's high-frequency ultraviolet light, which can cause skin cancer, cataracts, damage to plants, and harm marine ecosystems. Without it, life as we know it on Earth would be impossible.
So Roland and Melina made this prediction. But when was the actual ozone hole discovered? I seem to remember it was somewhere over Antarctica.
You've got a good memory. The definitive discovery came in 1985 when British Antarctic Survey scientists published findings showing a dramatic thinning of the ozone layer over Antarctica during spring months. They had been measuring ozone since the 1970s and noticed this recurring pattern of depletion.
Wait, so they had been collecting this data for years before they realized what was happening?
Interestingly, yes, the measurements were so extreme that at first they thought their instruments must be malfunctioning. It wasn't until they confirmed the readings with multiple instruments and years of data that they realized they were observing a genuine phenomenon.
That's incredible. So what happened next? This must have caused quite a stir in both scientific and political circles.
It absolutely did. NASA quickly confirmed the findings using satellite data, and suddenly this theoretical problem became very real. The media picked it up, and terms like ozone hole entered the public vocabulary. What's remarkable is how quickly the international community mobilized in response.
I'm guessing this is where the Montreal Protocol comes in. I remember that being hailed as some kind of landmark environmental agreement.
Spot on. The Montreal Protocol on substances that deplete the ozone layer was adopted in 1987, just 2 years after the ozone hole was confirmed. It's widely considered the most successful international environmental agreement ever created. Initially, 46 countries signed on, agreeing to cut CFC production and use by 50% by 2000.
Only 50%? That doesn't sound very ambitious given the scale of the problem.
You're right. And that's where things get interesting. As scientific evidence mounted about the severity of ozone depletion, the protocol was strengthened multiple times through amendments. The London Amendment in 1990 called for phasing out CFCs completely by 2000. Then the Copenhagen Amendment in 1992 accelerated the timeline even further.
So the agreement evolved as the science became clearer? That's surprisingly rational for international politics.
I know, right? It's a rare example of global governance actually working. And here's what's particularly impressive. The protocol has achieved near-universal ratification. Every member country of the United Nations, 198 parties, has ratified it, making it the first treaty in the history of the UN to achieve universal ratification.
That level of consensus is almost unheard of. But I'm curious about the economic impact. CFCs were in so many products: refrigerators, air conditioners, industrial processes. Did industries push back? Was there economic chaos when these chemicals were banned?
That's one of the most instructive parts of the story. There was certainly initial resistance from some industries, particularly those manufacturing CFCs like DuPont. But something fascinating happened. Once the writing was on the wall that these chemicals would be phased out, industries began innovating and developing alternatives.
So instead of fighting the regulations endlessly, they adapted?
They did. Companies realized there was profit in developing alternatives, and the transition happened much more smoothly than many had predicted. The total global cost of CFC phase-out ended up being much lower than initial estimates. And critically, the phase-out included provisions to help developing countries transition through what was called the Multilateral Fund.
I'm guessing we don't hear much about the ozone hole these days because the problem was solved? Or has it been overshadowed by other environmental crises?
Both, actually. The Montreal Protocol has been remarkably successful. Atmospheric concentrations of CFCs peaked in the late 1990s and have been declining since. The ozone layer is showing clear signs of recovery. According to the latest scientific assessments, the ozone layer should return to pre-1980 levels between 2050 and 2070.
Wait, 2050 to 2070? That's still decades away. Why is it taking so long if we've stopped producing the chemicals that cause the damage?
That's the thing about environmental problems. The timescales can be long. CFCs have lifetimes of 50 to 100 years in the atmosphere. So even though we've dramatically reduced their production, the ones already released are still up there doing damage, just at a decreasing rate. It's like turning around a supertanker. You can't do it instantly.
That makes sense. So the ozone layer is healing, but slowly. However, I've read some scientific articles suggesting the story might not be as straightforward as we banned CFCs and fixed the problem. Are there legitimate scientific critiques of this narrative?
That's an excellent point, Donna. The simplified story often overlooks some important scientific complexities. For one, there's significant natural variability in ozone levels caused by solar cycles, volcanic eruptions, and atmospheric circulation patterns. Some researchers have questioned how much of the observed recovery is due to the Montreal Protocol versus natural variability.
So it's hard to separate the human impact from natural fluctuations?
Exactly. Plus, the mechanism of ozone depletion is far more complex than simply CFCs float up and destroy ozone. It requires specific conditions, particularly the presence of polar stratospheric clouds that form in the extremely cold Antarctic winter. These clouds provide surfaces for the chemical reactions that break down ozone.
Which explains why the hole appears primarily over Antarctica.
Precisely. Some scientists have pointed out that the ozone hole is partly a natural seasonal phenomenon that CFCs exacerbated, not something created entirely by human activity. There are also technical debates about measurement, methodologies. How we define and measure recovery isn't universally agreed upon.
Are there any alternative theories about what might have caused or contributed to ozone depletion?
Some researchers have investigated whether cosmic rays or other atmospheric phenomena might play roles in ozone dynamics. And interestingly, despite the rapid phase-out of CFCs, the slowness of recovery suggests other factors may be at play. The Antarctic ozone hole has shown remarkable persistence, even as CFC concentrations have declined.
So while the Montreal Protocol was certainly important, the full story is more nuanced than most people realize.
Absolutely, it's a case where the popular narrative is somewhat oversimplified. That said, most atmospheric scientists still agree that CFCs were the primary driver of the enhanced ozone depletion we observed, and that their reduction has been beneficial. But the relationship is more complex than direct cause and effect.
That's fascinating. Setting aside those scientific complexities for a moment, what should this teach us about our current climate and environmental challenges? Are there lessons we can apply to issues like climate change?
That's the million-dollar question, isn't it? There are several important lessons. First, the ozone crisis shows that global environmental problems can be addressed through international cooperation when there's political will. Second, it demonstrates that scientific understanding, even if incomplete, can successfully drive policy action.
But climate change seems so much more difficult to address. Why is that?
You've hit on something crucial. While the ozone problem and climate change are both global atmospheric issues, there are key differences that make climate change a tougher challenge. With the ozone hole, we were dealing with a specific group of chemicals with specific commercial applications. Replacements were relatively straightforward to develop.
Whereas with climate change, we're talking about carbon dioxide and other greenhouse gases that are fundamental to our entire energy system, transportation, manufacturing, basically modern civilization.
Exactly. The economic stakes and transformations needed are orders of magnitude larger. Also, the benefits of action on CFCs were relatively immediate and tangible. Reduced cancer risk, protecting ecosystems we depend on. The benefits of climate action are more diffuse, distant in time, and harder to connect directly to individual actions.
Plus, I imagine there was less organized denial of the ozone science. It seems like the scientific consensus was accepted more readily.
There was some pushback initially, with some industry groups questioning the science. DuPont, the main manufacturer of CFCs, initially contested the findings. But you're right. The campaign to sow doubt about ozone depletion was nothing compared to the well-funded climate denial movement we've seen over the past few decades.
It's fascinating to think about this as a case study in environmental problem solving. Are there other factors that made the ozone issue easier to solve than climate change?
Definitely. The ozone problem had a much clearer cause and effect relationship that was easier to communicate to the public. Scientists could point to specific chemicals made by specific companies causing a specific problem. The solution was also clearer: phase out these chemicals and develop alternatives.
That reminds me. I was a kid when all this was happening, and I remember this very tangible fear about the ozone hole. People were genuinely scared of getting skin cancer, and it felt like something that could affect you personally.
That personal connection is significant. The threat of increased UV radiation causing skin cancer created an immediate sense of personal risk that helped drive public concern and political action. Climate change, despite its greater long-term severity, often feels more abstract and distant to many people.
So, looking at where we are now with the ozone layer, would you say it's a success story?
I would. It's one of humanity's great environmental success stories, though the work isn't completely finished. We still need to monitor the recovery and ensure continued compliance with the Montreal Protocol. And interestingly, some of the replacement chemicals for CFCs, called hydrofluorocarbons, or HFCs, while safer for the ozone layer, turned out to be potent greenhouse gases.
Oh, that's ironic. So, solving one environmental problem contributed to another?
Unfortunately, yes, but even there's a positive development. In 2016, the Kigali Amendment to the Montreal Protocol was adopted, which aims to phase down HFCs as well. It's an example of how environmental governance can adapt to new scientific understanding.
I'm curious. Why do you think the ozone hole isn't discussed much anymore? Is it just because we solved it, or is there more to it?
That's a fascinating question. I think there are several reasons. Yes, the successful international response is part of it. Problems that are being effectively addressed tend to fade from public consciousness. But there's also the reality that our attention has shifted to more pressing environmental threats like climate change, biodiversity loss, and plastic pollution.
I wonder if there's also something about generational memory here. People my age and older remember the ozone crisis vividly, but younger generations have grown up in a world where it was already being addressed.
That's an excellent point. Environmental concerns seem to be somewhat generational. Each generation grows up with its own set of environmental anxieties. For people growing up in the 2020s, climate change, extreme weather events, and resource scarcity are much more immediate concerns than ozone depletion.
So, what should we take away from the ozone story as we face these seemingly more intractable environmental challenges today?
I think there are several key lessons. First, never underestimate the power of international cooperation when it's guided by strong science. Second, technological innovation can often provide solutions once the right incentives and regulations are in place. And third, environmental problems that seem overwhelming can be addressed successfully if we approach them with determination and flexibility.
Those are important takeaways. I also think the ozone story shows us that preventing environmental damage is better than trying to repair it later. Even with our successful intervention, the ozone layer will take nearly a century to fully recover.
Absolutely. Prevention is far more effective than remediation. And perhaps the most encouraging lesson is that humans are capable of making significant changes to protect our planet when we understand what's at stake. The ozone story is ultimately hopeful. It shows us that global environmental challenges can be overcome.
Well, this has been an illuminating conversation, Yakov. Who knew that this environmental blast from the past could offer so many insights for our current challenges?
That's why I find environmental history so fascinating, Donna. The challenges change, but many of the fundamental questions about how we balance human progress with environmental protection remain the same.
Thanks for taking us on this journey through the ozone crisis and its resolution. And thanks to all our listeners for joining us today on Innovation Pulse. We hope this discussion has given you some food for thought about how past environmental victories, even with their scientific complexities and nuances, might inform our approach to current challenges. Until next time, remember that our environmental history is full of both cautionary tales and success stories, and we get to decide which category our response to today's crises will fall into.
Couldn't have said it better myself. See you next time, everyone. As we wrap up today's podcast, we explored Hyundai's and Kia's triumphs at the 2025 New York International Auto Show with their electric vehicles, and revisited the lessons from the resolution of the ozone hole crisis, reminding us of the importance of global cooperation in environmental challenges. Don't forget to like, subscribe, and share this episode with your friends and colleagues, so they can also stay updated on the latest news and gain powerful insights. Stay tuned for more updates.